Hello friends. Friends, today we will discuss about electric field intensity and electric lines of force or field lines. Now, first of all, we will discuss what is basically electric field intensity. By definition, it is defined at any point as the force experienced by a unit positive charge. A force experienced by a unit positive charge placed at that point. Okay, so it is defined at any point as a force experienced by a unit positive charge placed at that point. The electric field intensity at any point is the strength of electric field at that point. That is, what is the strength of electric field at that point? Now, for example, if F is the force acting on a test charge plus Q naught at any point, then electric field intensity at this point is given by E is equals to F by Q naught. Q naught is the test charge, the unit positive charge. Okay, so electric field intensity, it is a vector. The direction of electric field intensity is the same as the direction of force. That is, E is along the direction in which the test charge Q naught would tend to move, because the force will move that charge and the direction of electric field intensity will be along the direction of the force. The SI unit of electric field intensity is Newton per Coulomb. Now, what is the physical significance of E? We can calculate the magnitude and the direction of the force experienced by any charge held at that point in the electric field. That is, F is equals to Q naught E. So if we know the magnitude of charge, then we can find out the magnitude and direction of the force experienced by any charge held at that point in the electric field. Electric lines of force or field lines. Now we have understood the definition of electric field. Now whenever there will be electric field, there will be electric lines of force. It's just like the magnetic lines of force due to magnet. Similarly, a charge may be a positive, a charge may be a negative. They must have electric lines of force, because due to these electric lines of force, one charge can attract another charge or repel another charge. Okay, so electric line of force is a path. It may be straight or curved, such that the tangent to it at any point gives the direction of electric field intensity at that point. Okay, see the figure 1. Now here PQ is an electrostatic line of force. The tangent to the line at any point A gives the direction of electric intensity EA at point A. Similarly, tangent to PQ at point B gives the direction of electric intensity EB at point B. Now, I hope you are aware about the tangent. Now, for example, we have a circle and tangent is a line that is touching the outermost point, this point, just this point. Now, this line is known as the tangent. Okay, here this line is known as the tangent. Here this line is known as the tangent. Here this line is the tangent, because it is just passing through this point C. Okay, so if this is a curved electric line of force, then at point A the direction will be tangent to that point. At point B the direction will be tangent to that point. Okay, so direction of electric field lines for positive, negative and pair of equal and opposite charges. For a single positive point charge, These lines are radially outwards like this. You can see the directions are outwards. The directions are outward. They are directed radially outward. The lines of force extend to infinity. There is no particular end. Okay, because they are originating from here and going outwards for a single positive point charge. For a single negative point charge, these lines are directed radially inwards. Okay, inwards. And for a pair of equal and opposite charges like here, positive, negative, lines of forces are shown like this, because we have just learnt that from a positive charge, directions of lines of force will be outward. But when there will be a negative charge, these outward lines of force will be attracted towards the negative charge, just like here. Okay, so they are originating from the positive charge and they are going into the negative charge. That's why there is also attraction between positive and negative charges. Okay, so we have learnt about the positive charge, the negative charge, and the pair of equal and opposite charges. Now, properties of electric lines of force. Electric lines of force are discontinuous curves. They are discontinuous curves. They start from a positively charged body and end at a negatively charged body. No electric lines of force exist inside the charged body. There cannot be any line of force inside the charged body. Tangent to the line of force at any point gives the direction of electric intensity at that point. Okay, and the third one, the most important one, no two electric lines of force can intersect each other. This question is asked many times. No two electric lines of force can intersect each other. This is because at the point of intersection P, we can draw two tangents P and PB to two lines of forces. PA and PB to the two lines of forces. This would mean two directions of electric intensity at the same point, which is not possible. Okay, if we try to draw at point A two tangents, okay, but at point A there will be one tangent. Okay, but if we try to draw two tangents PA and PB to the two lines of forces, so there will be two directions of electric intensity at the same point, which is not possible. Hence, no two lines of force can cross each other. Thank you. I hope you have understood about the meaning of electric field, lines of forces, and their different properties. Thank you. Thanks a lot.